Hello students. In our last lecture we ended on describing Newton's laws of motion, where we described the three Newton's laws of motion. In this time lecture we are going to look on the numerical examples basing in Newton's laws of motion. In short, we are going to check how we solve various problems by using the Newton's laws of motion. Okay, let's start with the problem number one. Problem number one states that find the linear momentum of a body of mass 5 kg moving with the velocity of 2 meters per second. Now, solution for this problem. First of all, we are writing down the data given. Therefore, in our question here, we have given mass of a body which is 5 kg and the velocity of a body which is 2 meters per second. But we know that we already know the formula for calculating momentum, because we studied it earlier there in the first lecture, that momentum, which is represented by capital M, is given by the product as a product of mass of a body and its velocity. Therefore, as we already have been given mass of a body and the velocity of a body, therefore we are able to calculate its asked momentum. Therefore, putting these values in this formula, we obtain the value of momentum equal to 10 kilograms meter per second. Therefore, that was the problem number one. Coming to the problem number two, we are asked that a football was kicked into hands of a goalkeeper at 4 meters per second speed. The goalkeeper stopped the ball in 2 seconds. So we have given a reaction time here. If the mass of a ball is 0.5 kg, calculate the average force exerted on the goalkeeper. Therefore, the first step before all is first noting down the all data which we have been given in this question. Now, noting down the data given, the first one is initial velocity of the ball, which is represented by small u, which is equal to 4 meters per second. And the second data is the time reaction, this one, 2 seconds. The third one is mass of the ball, which is 0.5 kg. And the last one is the final velocity of the ball, which is represented by the capital V, which was 0 meters per second, since the ball was finally stopped. What is required here is to find the average force exerted on the goalkeeper. Therefore, to solve such kind of a problem, we use the Newton's second law of motion. Actually, when you describe this problem from the data given, you will automatically know that the equation here which has to be used is that from Newton's second law of motion, which is force equal to mass times the acceleration. See, but in our formula here we have not given, in our problem we have not given an acceleration, but from the data given here we are able to calculate acceleration. And as we know that acceleration of the body is given by this formula, that is final velocity minus initial velocity over time. But we see here in our data we have all these values. Therefore, it means we are able to calculate the acceleration of the body. Now, substituting this value of A here in this equation, our equation here becomes in this form. As you see here, F equal to M, the letter A from here has been replaced by this expression here. Therefore, putting those given values in the data given here, it will become 0.5 kilograms, brackets, final velocity is 0 since the ball was stopped finally. The initial velocity as given was 4, and the time reaction was 2 seconds. But here we know this is acceleration. This expression means acceleration. Therefore, the SI unit is meter per second squares. Now, on working out this stuff here, the final output is negative 1 Newton. So this represents the force which was exerted, the average force exerted by the goalkeeper. I think you have understood it there. Let's check the problem 3. What force is required to give a mass of 0.2 kilogram and acceleration of 0.5 meter per second square? As you have been discussing earlier, the first step that we have to do here is to note down the data so we can be able to determine which formula to use. Here we have given mass of a body, which is this one, and acceleration of body, which is this one, and we ask you to calculate the force. We know that from Newton's second law of motion we obtain this equation which can satisfy our problem over here. So upon substituting or upon putting these values in this question, we get the final answer, which is the force equal to 0.1 Newton. I think the expression is well understood because it explains itself. It is too open. Okay. Then coming to the problem number 4, which asks what acceleration will be given to a body of mass 6 kg by a force of 15 Newton. Then what is step to do here is first writing the data. We have given mass 60 kg, force 15 Newton. We ask you to find the acceleration. Again here we see the formula that will fit here. It's that from Newton's second law of motion, which is this one. And because we ask you to find the acceleration, so therefore we'll make the acceleration the subject of the formula, which is this formula becomes A equal to F over M. F is force and M is mass. Because all these values have been given here, so we just put them, and what we obtain here is 2.5 meter per second square. Therefore, this is acceleration that will be resulted from this body. Those are commonly numerical examples of Newton's laws of motion. For today, we end there. Thank you. Please don't forget to subscribe so as to get more and more stuff about physics. Thank you.